All right, one of the methods that we talk about when we are solving quadratic equations is going to be by completing the square. And from my experience, this is often glossed over in algebra, and teachers don't cover it, and it's we just got through it, but we didn't really understand it, kind of thing. So what I'm going to do is I'm going to skip to the end, completing the square. Uh, we'll start with the square root property, and that's just saying that we can solve. We see it actually looks like the difference of squares, but we can use the square root of both sides to solve an equation. Understanding that if x squared equals 21, we can find the square root of both sides. You know, the square root of x squared, if we found the square root of one side, we find the square root of the other, and then that's why they're saying that the answer is plus or minus 12. So here, we want to get to the point where we have a perfect square. So here, looking at this, I moved it over here that when we were to factor that, that would be what values of factors of 4 add up to negative 4. So we had x minus 2 times x minus 2, which is actually x minus 2 squared. That's what we have, right? X minus 2 squared. So we just rewrote that into this value. Plus 25. Now you can find the square root of both sides. Because remember your square root, I have 2x minus 2 squared, so I like to think that, we're going to simplify that just to x minus 2, plus or minus the square root of 25, so we know that that could be either a positive or a negative number. So we get to this point where they found the square root of 25, so we have x minus 2 is equal to plus or minus 5. Then we have an equation. So you have 2 plus 5, you have 2 minus 5, right, plus or minus. And then they found their answers, and it's going to be negative 3 and 7. So just being able to get to the point where we can do the square root property, and then simplify, and then later on we'll talk about how it got us into the vertex form. But how quickly it can get us into the vertex form right here, that is, we will not speed too far ahead. Let's go on. Now here, using the square root property, we want to, hopefully, the square root of 361 is 19. But go ahead and try this one, and then I will have the work here, but stop the video, give it a shot, and then check your answer. Okay, so found the square root of 24. Square root of 576 was plus or minus 24. So creating this equation, I have x minus 19 is equal to 24, or x minus 19 is equal to negative 24. And then adding 19 to both sides. And then x is going to be equal to 43, or x is going to be equal to negative 5. So those are your two possible answers when we factored that. Okay. Again, looking for that perfect square, factoring. Since a was 1, I can factor that pretty easy to know that x times x, and then what values of 19 will give me a negative number. So I know it should be negative 19 times negative 19 So that factoring process is going to continue on and say this is coming back here, here, doing the same thing with irrational numbers. Now, irrational numbers, we're going to get to this point because simplifying the radical is going to, we're going to need practice. But here we have what we do have a perfect square over here. 12 times 12 is 144. 12 plus 12 is 24. So we know we have x plus 12 squared. And there you go. I factored it for us so we could see it. So we can find the square root of both sides. The square root of x plus 12 squared, the square root of 192 is going to give me x plus 12 is equal to plus or minus the square root of 192. Now at this point, you do have the option to convert it to a decimal. So approximate square root of 192 is 13.85 and some decimals. I just rounded it to 13.9. Again, it's an approximate now because we rounded it, and then you can go ahead and, you could have x plus 12 is approximately equal to a positive 13.9, or x plus 12 is approximately equal to a negative 13.9, and then we can solve the same way. The process of simplifying that radical, though, we know that the square root of 192 is the same thing as 64 times 3, and then we know that the square root of 64 is 8, so I can bring that out of the radical, and then the square root of 3 I can't do anything with, so I leave it in. So again, this is something that we've learned along the way, but if you're challenged with this, we can just convert it to a decimal and come up with the same answer, virtually the same answer. You do have to be able to convert back and forth. If they give you a radical and you have a decimal, you need to be able to figure out which one are equivalent statements and which ones are not. So there you go. Let's see, what did I miss out on here as I was explaining? This would be minus 12, and this would be minus 12. And then when they converted that to a decimal, it looks like, well, they did this radical thing. They have both my answers there and then converted it to a decimal. So there you go. That is understanding the general square root process. Equations with complex numbers, again, we're not going to do that. It's the same difference, but we're just using that imaginary number. We're doing the exact same actions. And then we are going. Here, completing the square. Now, understand how to complete the square. When we don't have a perfect square that we can deal with, we want to create that perfect square. So it says find 1/2 of b and the coefficient and then square the results. Let's look at this in practice. So if I have, let's just say if I have x squared plus 10x, what value is going to give me a perfect square root? Well, I'm hoping that we would look at that and say, well, if I were to say plus 12, I don't know where I wrote down 15 said 12, how about plus 25? That would actually be x plus 5 times x plus 5. That's what we're looking at. That we just completed the square. But if I had an equation, if I added 25 to one side, I would have had to add 25 to the other to maintain that perfect equality. So that's why that's what they're talking about, completing the square. What value did I have to add here to complete the square? And then I'm to that point now where it looks like what I can deal with. Okay, so again, we're completing the square with some value, and if you add a number to one side of the equation, you have to add that number to the other side of the equation to maintain the equality. So understanding the process, what did we do to get that 25? Well, we knew that half of this is 5, and then we squared it. 5 times 5 is 25. 5 plus 5 is 10. So we were just creating this where we could get this factored form to where we could get the perfect square. So here, solving by completing the square, and I'll just say that this is the whole process they're talking about right there, is finding that value of C. I just gave us an easier number to deal with. They gave us a fraction to deal with. But again, half of the B value is -7. -7 over 2 would be 1/2, or that would be -3.5. Then they turn around and square it. So -3.5 squared is, not sure of the number. I think it's -12.25. So add the results. So there you go. We have 12.25. So now that can be written as x minus 3.5 squared, getting us to that position that we want to be in. Here, let's see, what they've done here is they've said, hey, to complete this square, we're going to move this number over to the other side. So now I'm left with just x squared plus 18x. And then I want to complete the square with this. So half of this squared, 18, half of 18 is 9. 9 squared is 81. So they added 81 to one side of the equation. So they had to add 81 to the other side of the equation. Then they were able to factor this. X plus 9 squared is this factored. They combine like terms, equals 85. And then right here, they found plus or minus the square root of 85. They found the square root of both sides. And the square root of x plus 9 squared is x plus 9. And then the square root of 85, they're just gonna leave it in radical form here. So they went ahead and subtracted 9 from both sides, and that's how they came up with -9 plus or minus the square root of 85. So getting from here to here, that's the mathematical process, doing my inverse operations. Now if I go back to this, x plus 9 squared equals 85. If I were to subtract 85 from both sides, that is vertex form. X plus 9 squared minus 85 equals 0, and your h and your k, so my vertex would actually be, I won't put that, let me spell vertex out, right? The vertex of this is actually going to be -9, -85. So that's what we're trying to get to, really. That's the most useful portion of this activity, is getting to the point where we understand what the function is doing and its characteristics. We are going to the, here, this gets a little bit more challenging, but when completing the square, you have to have an a value of 1. So that's what they've done here. In standard form, or in order to complete the square, your a has to be the value of 1. So this is 4. So what do they do to make 4 into 1? They divided everything by 4. And that gives me just x squared. And then they did the completing the square process. And it becomes a little bit more convoluted because we are dealing with fractions, but they went ahead, -12 divided by 4 is -3, and then -27 divided by 4 is -27 over 4. They moved this number over to the other side, right? So they added -27 over 4 to both sides. Now they're in a position to complete the square, and they took 1/2 of -3, which would be -3/2. That would be -3 over 2 squared gives me 9/4. Okay, so that's the process that they're looking at here. And as they continue on, it's fractions, but mathematically we're doing the same operations. I know that x minus 3/2 squared, this factors to x minus 3/2 squared equals, when I combine these two fractions, it comes to 9. So it just got easy for us. So when I found the square root of both sides, I have x minus 3/2 is equal to plus or minus 3, and I can continue to solve that equation. Now here, for the sake of this class, we are only going to get to, honestly, to this point. This is where I want to get with this kind of problem. So I would say work on the first couple of steps here and see if we can get to this step. That's my goal. We want to get to factoring into that vertex form. And it looks something like, and I hate that they put this fraction in here like this, really challenges us. I went ahead and subtracted 9 to both sides, divided by 6 so I can get x squared. And then here we have to find half of this and square it. Well, half of negative 7/2 times 1/2 is negative 7/4. So negative 7/4 squared is going to be 49 over 16. If you add it to one side, you must add it to the other. And then when we factor this, we know then that becomes x minus 7/4 squared is equal to, when I combine these, let's see here, that would be 49 over 16 negative 3/2, which is the same thing as 24. So that should be 25 over 16. 25 over 16. So we can actually find the square root of both sides here. This is the goal to get to this step so we can go to vertex form. But if I were to find the square root of both sides, that would be x minus 7 over 4 is equal to plus or minus 5 over 4, because if you notice, 25 and 16 are both perfect squares, so I can actually find the perfect square there. And then we could continue processing that equation going through the steps. But really the goal is being able, in this challenging problem, is being able to get to the vertex form. Use of the quadratic functions in vertex form. That's my goal, that's our goal. And this again is that algebra skill, that the vertex form of a quadratic equation. You know, we had the standard form, ax squared plus bx plus c equals 0, and we got some use out of it. But vertex form is really very useful, and this is what we want to get to. So you have a, same thing as in standard form, it stretches, shrinks, it manipulates. You have x and k, which we have covered in the past already in this course, but h and k are going to be my vertex of my quadratic equation. And of course the a, whether the a is positive or negative, will tell us whether it is going up or going down. But just being able to get to this point is really the goal of getting to the location of the vertex. So looking at that, and you can see here in this example that when I have 2 times x plus 3 squared minus 2, this is going to be negative 3, because again, this formula is a, or in this case, we'll just say it's 2 times x minus a negative 3, because the formula calls for a minus, so in order to get a plus 3, we had to have minus a negative 3. Minus 2, and then just being able to say, hey, this is the x value at my vertex, this is the y value at my vertex. So looking at this is where we're going when we talk about completing the square. And again, here's that vertex form that we talked about earlier. Understanding that here's my standard form, here is my vertex form. This is written in standard form, this would be written in vertex form. And I will just say, how did they get to that? They factored a 2 out, and that would be x squared plus (6x) plus some number that we're going to complete the square on plus 16. And then when you complete the square, you would say, hey, half of 6 is 3, 3 squared is 9. All right. going to be 9. If you add 9, though, you have to subtract 9. Subtract 9 because that is the value of 0, 9 minus 9, because I didn't put it on the other side of the equation. Now, when I take this out of the, this is where it gets a little convoluted. When I take this out of my parentheses, I have to make sure that I multiply it by 2. So it's actually negative 18. So I have y equals 2 times x plus 3 squared minus 18 when I take it out of the parentheses plus 16, and that's how they came up with negative 2. Negative 18 plus 16 is negative 2. Takes a little bit of practice. So let's see here. Working with this, writing the function in vertex form, that's our desired result. I want to be able to, I want that positive, right? So when they isolated their variables to where they could complete the square, they went ahead and factored out a negative number. So I have negative times, and then when they completed the square, half of 12 is 6, 6 squared is 36. In order to do that, though, they had to add and subtract 36, because this is the value of 0. They haven't changed the value of the function that way. When they factored this 36 out, negative times a negative became a positive. We can complete the square here. So again, this is going to be negative x plus 6 squared plus 27. Hopefully they're not all that difficult. But let's do the check here real quick. Okay, so I'm just thinking about what number do I have to add, or what number would complete the square for 8x. That would be half of that is 4, half of that squared, 4 squared is 16. So I will add 16 and subtract 16. So now I can take and complete the square with this, and that is x, just think about it, x plus 4 times x plus 4 is minus 19, because I just took and factored that. That would be x plus 4 squared minus 19. And I just completed the square. And my vertex here should be negative 4, negative 19. Completing the square. This example right here is a little bit more challenging because we do have we're going to have to factor something out so we can complete the square. So we have negative 3x squared minus 6x, and I'm just going to throw that minus 5 over there. I'm going to go ahead and factor out negative 3. So negative 3, and that would be x squared minus plus 2x, right? Because I factored out 3. And then still have negative 5 on the outside. So completing the square, half of that would be 1. Half of that 1 squared is 1. So if I add 1, I must subtract 1. So I can now complete the square with these 3, and then I just need to make sure that I bring this out of my parentheses. So negative 1 times negative 3 is going to be 3, positive 3 minus 5, and then I end up with x squared plus 2x plus 1, and then that would be negative 3 times x plus 1 squared minus 2. There you go, that would be my solution there, and I see that my vertex again is going to be negative 1, negative 2. That's the goal, to get to that vertex form. Spelled vertex way wrong there. That's the goal of this whole process. And determining the vertex and axis of symmetry, again, that vertex, once you have the vertex, we know here that h is a 2, k is negative 7. So your axis of symmetry, as we go through the vertex, your axis of symmetry is x equals whatever your vertex number is. So in this case, in this example, they've completed the square. So we know then that x is going to be equal to h, so x is going to be equal to 2. Finding the vertex and determining if it is a maximum or minimum, the vertex here should be a 2, -7. And since a is positive, we know that it opens upward. So the vertex is actually a minimum. And that's the kind of thing, that's what we're learning this whole process for, is so we can start identifying characteristics of our equation. And I will just say that we're going to do a lot of this in class. It is a review, but it's often overlooked in previous math classes. So we'll go forward, we'll keep doing this, and again, if we can get to this, that's our goal, okay? And we'll get some practice.